So how do we know what we do know about the geological and biological origins of our country? What clues exist all around us, even now, to the ancient prehistoric past? What more do we have to find out? And what debates currently rage within the specialized fields devoted to these discoveries that we lay people simply don't hear about? So let's define our terms. Zealandia. It's not a piece of music necessarily. It's not just a term that sounds quite romantic. When we talk about our ancient geological past, what do we mean by Zealandia?
Well, let me answer that. Zealandia was first coined in the scientific literature in 1995 by an American geologist, Bruce Lyondike. And he works on the magnetic properties of rocks. And he was the one who used that term. And we Kiwi geologists have really taken to it. There have been other names, which for one reason or another have all been inappropriate, not quite on the mark. So we really like Zealandia. So it's been around that long. And what it refers to is our chunk of continental crust, which broke away from Gondwanaland in late Cretaceous time. And it moved as a very substantial chunk of land to the northeast of the Gondwanaland margin.
When you say Cretaceous, some of us know, but for the others.
All right.
How long ago was that?
Right. The Cretaceous period, just to remind you, is between 144 million years ago and 65 million years ago. And we take if you like, the clean break, the point of separation at 83 million. And we do that because that is the age of the oldest sea floor in the Tasman Sea.
The other parts of that landmass that broke away from Gondwanaland, it's not just what we now call New Zealand. There are other outposts of it, are there?
Well, what we've come to realize in the last few decades is that the extent of this continent, Zealandia, is huge, and it's largely submerged. So we now regard New Zealand, New Caledonia, and a few of the other islands around as the emergent bits of Zealandia, which is otherwise 93% submerged.
Do the Chathams come into that?
Yep, the Chathams is part of.
So we're actually part of the same land mass.
But I like the idea that Cook actually got it right. You know, he just didn't realize that it had sunk.
All of those things have obviously evolved since Zealandia broke away. Do you have a picture in your mind of what Gondwanan biology, what the place was like at the time of the separation or the rift? Are we building a picture like that, George?
We are. It's nowhere near as complete as we'd like it to be, simply because we have to get that information from the fossil record. And the fossil record is quite good as far as plants are concerned. We have a pollen record. The pollen grains last for just about ever, and they get into rocks and into coal and so on, and can be recovered. So we have a measure of what the vegetation was like before it split away, the Zealandia block, and after it had split away, and of course what's there today. So you can trace the history of our plants through the record. What you don't have is a good record of animals, unfortunately. And most of the fossils that we might well be talking about later on tonight, New Zealand animal fossils, are all in very recent times, apart from one group, which I think we should talk about at some stage, from the Otago region. But most of the fossils that you hear about, the moa bones and all the birds that we know went extinct and so on, those are very recent fossils, much less than 1 million years. We're talking a few thousand.
Well, it was huge. It was a supercontinent. And the word Gondwanaland actually means land of Gondwana sequences. And a sequence in geology is a stack or series of layers or formations of distinctive rock. And you could find, the early geologists were able to identify a particular motif or sequence of rock in India initially, and they found the same sequence in Antarctica, South Africa, South America, Australia. And so that's what Gondwanaland means. It means land of Gondwana sequences. And it was really very distinct from the rocks in the other big continent at the time, which is Laurasia. So Gondwanaland is a huge supercontinent, and it began breaking up about 150 million years ago. And let's see, our continent broke away 83 million years ago, and the final two continents to break away are Antarctica and Australia, and they broke away about 34 million.
Whatever hit the dinosaurs everywhere in the world hit them in New Zealand too, because they all went extinct 65 million years ago. And that marked the end of the Cretaceous period. So it was a big event at that time, which annihilated that form of life.
So something, but whatever was here, essentially was on its own once it had.
It was, yes.
Once it had
What
moved.
In terms of terrestrial life.
Yeah, we're talking terrestrial life. Let's get that straight, not marine. We have good marine fossils of animals and plants, particularly animals, going right back through this time. But we're talking tonight, at any rate, about things that are confined to land, because land is the crux of this. But it's, I think most of us are aware that it's a fairly unstable piece. The piece that we're on now, this is probably some of Hamish's story, is up in the air as high as Mount Cook and so on because of tremendous earth pressures that have squeezed this land up. It was previously under the sea. And those pressures that keep us up above the ocean surface make it a fairly fragile sort of place. And it cracks and breaks and has volcanoes and earthquakes, all of which are not very conducive to keeping fossils quietly bedded in a rock so you can find them.
Well, if I can paint a picture of Zealandia as I think of it, it was a very substantial landmass. It wasn't especially mountainous. It was subdued. It was like Australia today. And it was pulled apart, rifted away under tension. So here we are in New Zealand, and everything we see today is the function of compression, collision, pretty much. So I want you to envisage a gentle landmass with no significant volcanism, no significant mountains, and it's being pulled away, and it's carrying with it a cargo of Gondwanan plants and animals, which in time, as Finlay is suggesting, surely became, they were on their own. So they would have started evolving in their own sweet way from, let's take 83 million as clean separation. So from 83 million onwards. And as Zealandia pulled away, it slowly sank. And it did so because of this tension. It was being stretched and thinned and cooled. And that's why our continental crust is thin relative to all other continents. So Australia is 40 to 55 kilometres in thickness. We're only 20 to 25 kilometres. And that's why most of Zealandia is underwater. It's just not buoyant enough to hold its head up above water.
Yeah. I mean, I know this is disputed, but George, what's your particular feeling about what caused it? Are you one of the meteorites?
This impact on the surface of the world would have been absolutely colossal. And so much so that it would have annihilated most plant life from the dust and the activity in the atmosphere for maybe days, weeks afterwards. And if you take away most of the plant life and most of the world supported by herbivorous animals, they're going to go too. So unless you were small or living in a hole or in a dormant state at the time it happened, you're not going to come through an event like that. And there was a huge eradication of fauna. The bigger the animals, the more they fell.
When Zealandia took off, surely it wasn't a filter, dinosaurs only on this. They were all there.
Yeah.
So, even though we don't have fossils, I think we can logically argue, and we wait now for the evidence, logically argue that the mammals would have been here, and maybe, and of course, other reptiles.
There was a dinosaur fossil discovery recently in Nelson. In fact, you were on the telly talking about it, I seem to recall.
You've got to be careful. These were footprints.
Okay, footprints. That's right, yes. What was the significance of them?
Well, these are, this is our, shall we say, our best interpretation. It's the most plausible explanation for these particular features. And they get up to about 30 centimetres, and they're rather lumpy looking. They just look like an elephant has made a footprint. And they're point pressure features in sediment. And this sediment relates to an estuary, and the rocks are 70 million years old.
Why have they only been stumbled on in 2009?
Well, we've known about them for about 15 years, but only last year did we encourage the the particular finder, Greg Brown, a colleague of mine at GNS Science, who is a sedimentologist. He studies sediments. We encouraged him to publish. And I tell you, the reason, Finlay, is back to oil and gas. I mean, we've been looking at that formation. It's called the North Cape Formation. It's about 700 meters thick. And it only is exposed on land in northwestmost South Island, round, in particular, Whanganui Inlet. But we've been looking at these rocks, but because this formation is the very source rock formation for New Zealand's oil and gas in Taranaki.
My contention would be that the key to this is the life that was trying to live on that land, not the rocks. Rocks can be below the sea or above the sea. They still look the same. But life is very different when it's terrestrial life and it's put underwater for half an hour or more. It's gone.
Yeah.
So when Hamish says and writes that he can't find any evidence of land, and that's fair enough. It's pretty hard looking for evidence of small bits of land today, which is 20 million years after the event. Therefore, perhaps there wasn't any. And I find that, for one thing, not a good scientific argument, because it's using a negative sense of the thing. If you could find positive evidence of land, that's different. But if you can find no evidence of land to say there was none, is another story. So I believe you need to turn to the fauna and flora, the biota, the life on the land.
I think the trouble with the rocks is that they're black and white. They're either marine or not marine.
No, but you don't know whether the surface of them is below or above the sea level 20 million years later. And you don't need much land, and you don't need it for very long, but I would argue you've got to have some land somewhere. And it may not be existent on the present landmass of New Zealand. It could be somewhere offshore today, maybe as far away as New Caledonia. But if it was somewhere and it enabled the organisms that we call typical of New Zealand, and our plants and animals are quite exceptional in the world, some of them. The animals far more than the plants. Plants are really just a subsample of what most people have, but the animals certainly weren't. They were very different. And the only way those animals could be different, seeing they can't come from anywhere else, is that they are traced right back to this part of Gondwana. And they are part of, well, I see it as part of this cargo of organisms that came here with the land. And I don't think they've been destroyed.
Well, the drowning, maximum drowning, ladies and gentlemen, was 23 million plus or minus half a million. And George is referring to organisms. We have some fossils, a magnificent fossil locality in central Otago near St. Bathans. And these are lake sediments. They're between 16 and 19 million. So that's still, what is it? It's 4 to 7 million years after the time of maximum submergence. So that's an awful lot of time. You can achieve an awful lot. We humans have lost our tails in less than 5 million years.
Yeah, we've come into existence.
All because of probably a gene switch off saying, don't grow those bones anymore.
For questions from the audience and so on. You mentioned in passing, you know, one of the things that everyone knows about New Zealand, we have a truly freakish fauna. And is it purely the product of our isolation that we've developed this unusual bird life and I don't know, long-lived reptiles and so on? How unique are we in terms of the way you look at biota worldwide?
I think isolation is important. I think it is, and it's only if you accept that there was continuous land here. Because obviously if you don't accept that,
not that old story.
then we get back on our theme, which is migration, isn't it? You have got to migrate all of these organisms in the same form they presumably would have been, but we don't have the fossil evidence, before the drowning, onto this bit of land. Where did they come from?